everyone, welcome to today's Tech Talk, Speeding Up TensorFlow and PyTorch with Alluxio. My name is Regina and I will be your moderator. Before I introduce our speaker, I have a few housekeeping items. All participants are automatically on mute throughout the session. Also, we will be using Slack for Q&A, so we invite you to engage with us and the open source community on our Slack channel, which is alluxio.io/Slack. If you have any trouble joining, feel free to message me your questions via the GoToWebinar control panel located on the right-hand side of your screen. In today's session, you will hear from our presenter, followed by a Q&A session at the very end. Again, to ask a question, join our community Slack channel, which I will be happy to post in the chat box. Please don't hesitate to send in your questions anytime. No need to wait until the end. Lastly, today's session is being recorded and will be available for on-demand playback. A link to the presentation will also be emailed to you. I believe that covers all housekeeping items, so let's go ahead and meet our speaker. I'm very pleased to welcome Lu Qiu.
We'll quickly go through what is Alluxio POSIX API, and we are mainly focusing in how to deploy Alluxio in Kubernetes environment for machine learning workloads. And I will give some recent updates on our recent Alluxio POSIX development from the community. First, what is Alluxio POSIX API? So as you guys may know that Alluxio can connect to different remote storage and is able to catch the data from the remote storage locally and closer to your compute frameworks. And through Alluxio FUSE, we go one step further. You are able to access data in different remote storage, just like your local folder. And by using Alluxio's caching ability, you can even use those data just like your local data. And so it provides many benefits for many of the machine learning frameworks like TensorFlow, PyTorch, Caffe, because those frameworks, they are built on top directly with your local dataset. They actually may not be able to bundle to other storage systems, or it's hard for you to bundle to those storage systems. And by using Alluxio, you can directly connect those frameworks to those storage systems, and without need to like, oh, how can I modify my script, etc. And if you can see this folder, this graph here, is that after you mount different storage systems to Alluxio namespace, and then you can mount the whole Alluxio namespace as a local folder. So when you open this folder, it just looks like your local directory and have your local data. But actually, those folders, they may represent different remote storage. They may represent an HDFS cluster. They may represent an object storage. And those data, they are actually local data, which already cached by Alluxio, or they may be actually still reside in your remote storage. When you run the training job, we will fetch those data for you. Another benefit provided by Alluxio POSIX API is that instead of caching the whole data set, copy all the whole data set to each of the machine that running your training job, Alluxio helps you to divide the big data set in multiple pieces, in multiple blocks, and store those blocks onto different Alluxio servers. So for when you're running the training job, the data maybe reside in your local node, or the data maybe reside in the nearby worker nodes. It's pretty close, much closer than you need to reach out to your remote storage to fetch those data. And if one server crash, there are still other servers able to serve your request. So you don't need to worry about, okay, if I copy the whole data set into one like this, and the disk crash, what should I do? Do I need to wait for another day to copy the data again? So you don't need to worry about those things. And now we jump to our favorite topic about how to deploy Alluxio in Kubernetes for machine learning workloads. So it's really interesting to see that we actually didn't recommend to our users that you should deploy Alluxio in Kubernetes environment for machine learning. But all our users, especially those users that use Alluxio in production environment in their machine learning training, they deploy Alluxio through Kubernetes. So that must be a reason behind. So I think the main reason for that is that by using the cloud, by using the Kubernetes, you can really easily to provision a cluster and deploy your services. And also you can really easily to run a distributed training job through Kubernetes, like the Kubeflow or Arena. And you can use one click to run all the different distributed training on the cloud. And by using the same framework, we can also deploy Alluxio services in the. So the first step is that you can launch a cloud cluster, the Kubernetes cluster in the cloud. And then you can deploy the Alluxio services through a really quick way through Kubernetes. And the Alluxio services will be co-located with your training jobs. Alluxio services will be connecting to your desired storage. If you want to load the data into the cluster, Alluxio can help you to load your desired data set. And then you can launch your training job, which providing the data, the local folder, the mom-pom that provided by Alluxio to help you to access your data in the remote storage, all the data that already became cached in Alluxio. So that's the steps: provision the cluster, and then deploy Alluxio through Kubernetes, and then launch the distributed training job via Kubeflow. And then you can enjoy the training speed acceleration by catching data locally. Users who want to run the machine learning training can focus on their training logics instead of worry about how can I prepare the data, how can I connect to the remote storage or copy the data to the cluster. You only need to focusing on the training logics. Now I'm going to talk about how can we actually deploy it in the Kubernetes environment. And actually, there are 4 ways that we can deploy it. I don't want to introduce that many ways. But there is no a single way that already dominate in the Kubernetes world. I really hope so. So those ways are usually used by our community users. And some of the ways that actually are introduced to us by them. And they said that, oh, we prefer this way, we use this way in production environment. So I will introduce all this to you. But all these ways, they do the same thing, is that deploy Alluxio in the cluster. They may have some small variants of what they are actually good for. So the default way, which is the most basic way, is actually using the kubectl to launch Alluxio cluster in Kubernetes. It's usually using in some testing environment instead of the production environment, especially when your deployment is really simple. You only have several really short YAML files to deploy your service. And it also is useful when your requirement, you have some special requirement, which is not fulfilled by other deployment ways so far. Then maybe you should go for the kubectl way. And another way that introduced by our official documentation is the Helm. Helm is the package manager for Kubernetes. It's preferred over kubectl. And Alluxio have its shared Helm charts. So instead of providing all the YAML scripts and trying to find which part I need to modify on top of the YAML scripts, you can use our shared Helm charts and provide your desired modification aside from the defaults. And the Alluxio service can be deployed in one command through the whole cluster. It's also really helpful if you want to deploy Alluxio not in a single cluster. Maybe you use it for your online machine learning long-running servers, and you also want to run it for some testing or some experiments. So you want to deploy Alluxio through multiple different environments and multiple clusters. In this way, it's good for you to create a common template for Alluxio services and deploy Alluxio services through multiple environments without copy-pasting. And kubectl and Helm is actually the official ways that given out by our deploy Alluxio on Kubernetes official documentation. So feel free to check out the link here. Now I want to introduce 2 other ways, maybe not that commonly used, but it's actually really helpful in the production environment. So the one way is Alluxio CSI. CSI is called the Container Storage Interface. So it allows us to expose Alluxio as a persistent storage to the container applications like Docker, Mesos, Kubernetes. And by using Alluxio CSI, we don't need to implement a Kubernetes driver and put it into the Kubernetes package and waiting for their releases. We can develop the features that we want and release it. So from the Microsoft production use case, they actually use Alluxio CSI because it's easier for them to have some mount level access control. They want to have multiple mount for different use cases, and they may have one mount that is configured and is optimized for their read path by enabling some of the metadata caching. And they may want to use a wholly different configuration set for another mount that they want to optimize by the right path. So they can have different configuration for different mount. And they also can define that, okay, one team, you can only access one mount and the other team, you can only access another mount. So they are able to achieve mount level access control through Alluxio CSI. If you are interested in knowing more about Alluxio CSI and how Microsoft actually using it in their production environment, feel free to check out the previous Alluxio Day talk about how to speed up large-scale machine learning and deep learning job with Alluxio CSI. And there are also some links about the GitHub repo about our recent improvements. I really want to thank Bin Yang from Microsoft and Baolong from Tencent for developing the CSI. Now I'm going to talk about another variant that's Fluid. And Fluid, they have a really complicated description. So basically, Fluid is a wrapper around Alluxio. In the previous several ways, you still need to know that, okay, how do I need to configure Alluxio on Kubernetes? How do I want to deploy it? What workloads should be mounted? And all those stuff, you still need to take care of them. But Fluid is a wrapper around Alluxio. It helps you to manage all those things for you. What you need to do is that you need to define, okay, which data set I want to use and which local folder I want this data set to be available. And by using this way, the users, they have access control on the data set levels. So we can define that, okay, some users you can access data set A, some users you can access data set B. And all the logics behind, like how to configure Alluxio, how to install Alluxio, how to auto-scaling Alluxio, all those logics are taken care by Fluid. So it's a really good tool for you to try out Alluxio in your maybe testing environment. And after you enter production, you may want to make some modification and go to more advanced deployment ways. So just like showing in this graph, Alluxio is used as a cache runtime engine. And besides Alluxio, Fluid helps us to manage the data set, the volumes, the runtime, the cache, and the prefetch logics. All those things are taken care by Fluid. If you want to know more about why we need to develop Fluid and how it actually being used in production environment, feel free to check out the previous links about when Alluxio meet Kubernetes, why we create Fluid, and how to speed up the learning platform with Alluxio plus Fluid. And really thanks Chaoyang from Alibaba for developing Fluid. Okay, now we move to the next session about what's our updates in the Alluxio POSIX deployment. So as we mentioned before that Alluxio deployment, especially when Alluxio entered the machine learning world, is not a single company or single person effort. It's a community-driven collaborations. And community contributors from Nanjing University, Alibaba, Tencent, Microsoft, and Alluxio both have a huge contribution to this project. And it's already in use by Microsoft, Analytics Experts, and Boss. And we really want to make the Alluxio into machine learning world this solution to be more mature, and we want to like collaborate the efforts from other users. So in Alluxio 2.6.0, we have many of the Alluxio JNI FUSE enhancement. We improved the performance by eliminating the local RPC. We made it easier for other people to use by modularize the JNI FUSE library. We implement more FUSE operations to take care of not just the common rewrite path, but also take care of many of the other Linux commands to make Alluxio FUSE more close to the POSIX standard. Also, we fixed out the issues that we found when we are actually running machine learning workloads using JNI FUSE. And also, we add the matches so that we can better monitoring the JNI FUSE. So the enhancement is not stopping at 2.6. We still have many of the ongoing projects. And given by the Microsoft, we are continually improving the CSI integration and adding more features to make it more easily to use by users. And also, one huge pain point for many users is that how can we load data from remote data set to your local folder? And we are continually improving our loading performance by dynamically allocating the loading job across multiple servers so we can load the data faster. In the Kubernetes world, if we want to change the configuration, we don't want to just shut down the whole cluster and then launching again, which is pretty like we have some downtime. We don't want this to be happen. So we want to support updating the configuration during runtime. And also we have many of the FUSE enhancement like supporting the LibFuse 3, and we continually improving the FUSE performance by optimizing the remote RPC. In every week on Monday, 6:30 p.m., we will have a Alluxio community sync. In this sync, contributors from different companies, and they will join our sync to contribute some of the FUSE improvements back. And also we will discuss about how can we improve this project, how can we improve the stability, improve the performance, and how can we move this project forward and let it be more mature. So join our community sync and we can create the solutions together.
Thank you very much, Lu. Lots of great information. And I can see that we do have a few questions. So as a reminder, everyone, if you do wish to ask a question, please join us on Slack, or feel free to message questions through the GoToWebinar control panel, which is on the right-hand side of your screen. All right, our first question, in what cases should we deploy Alluxio POSIX API?
Yeah, thanks Regina for heading out the questions. So when we considering deploy Alluxio POSIX API, we mainly deploy it through like based on some of the use cases, based on the current use cases that we have. Usually when people considering deploy Alluxio, they are doing some like distributed training in the cloud. They have large amount of data and they have multiple nodes with multiple GPUs, and they want to accelerate their trainings. And for the data side, usually we target for a large amount of data, meaning like terabytes or even more. And when we also target like millions of small files. So in those cases, Alluxio can actually accelerate the training, and so they can actually utilize Alluxio's distributed caching or utilize Alluxio's caching ability to actually speed up the training jobs.
Great, thanks, Lu. We have one other question here. How does Alluxio accelerate training jobs?
Yeah, as I mentioned before, Alluxio accelerate training job multiple, mainly for two parts. One is that Alluxio can do the preload part. Before you start training, you can use distributedLoad or other commands to load your data into your training cluster. And that's one part is preload. And the second part is that even if you didn't do the preload beforehand, you can still use, actually Alluxio has built-in caching mechanism. When your training job requires you to read some of the data for the first time, and we know that it's not in Alluxio, we go to the UFS to fetch those data for you. And afterwards, those data can be cached in Alluxio. So next time when you do the training on the same data set, it will be much faster because the data is within the cluster. So that's main two parts, preload and also the loading when training.
Great, great. Thanks so much. I don't see any other questions here, but again, if you do have any other questions following today's session, feel free to engage with us on our community Slack channel. Thank you very much, Lu, for hosting today's Tech Talk, and thank you very much to our audience for joining us today. This concludes our Tech Talk. Thanks so much, and have a great day, everyone.
Thanks, Regina. Thanks, everyone.